pairs are really important ideas in mathematics because quite often we're taking a look at two things, two variables, and we want to see how they relate to each other. Now, traditionally, we write an ordered pair as x comma y, but sometimes we use other letters as well, so we shouldn't be sort of, confused when we see them. We have to keep in mind that once it's specified which comes first and which comes second, that's the convention. Let's take a look at an example and take a look at ordered pairs and see if they satisfy certain expressions. So the first one I want us to look at is the following equation. Y equals 5x minus 1. And the ordered pairs here are going to be given to us as x comma y. So the first number we see will always be an x value, and the second number we see is going to be a value for the y. Let's take a look at some particular ordered pairs and see if they satisfy this equation. Okay? So the first one I want us to take a look at is 2 comma 9. Does it satisfy this equation? Well, we check and see if, in fact, if I plug in a 9 for y and a 2 for x, so do we have a true equation? So let's see. 9, does that equal, so this is a big question mark now, does that equal, well, what we get when we plug in 2 here, which is going to be 5 times 2 minus 1. Well, remember the orders of operations. We first do the multiplication, so this is going to be a 10 minus 1 is 9. So yes, this equals 9, and this checks, and so yes, this is a point. How about this one? 5 comma 17. Well, to check that, what do? I let y now equal 17 and x equal 5 and see if this is satisfied. So here I ask, is 17 equal to, and I don't know if it is or not, this is an open question, is it equal to what I get when I plug in a 5 here? Well, that's 5 multiplied by this 5 minus 1. Well, that's 25 minus 1, which is 24, and so this is a no. This is a no, not equal, no. That's sort of sad. So that point, that ordered pair does not satisfy this. Let's try one last one. 21 comma 104. So remember, the 21 is the x, the 104 is the y. We insert 104. Does that equal, big mystery, 5 times 21 minus 1? Well, what does that equal? Well, 5 times 21 turns out to equal 105, and then minus 1 equals 104. So yes, we have a winner here. Neat. So you can actually verify if an ordered pair actually satisfies a particular equation by just inserting the appropriate value into the appropriate unknown and seeing if you get an identity. If you don't, then that ordered pair doesn't satisfy it.